Okay, class, got my microphone issue figured out. Today we're going to talk about linear inequalities. Linear means x to the first power, not x to the second or third or things like that, but x to the first power. Inequalities, less than and greater than, stuff like that. And so we're going to start by looking at compound inequalities, a review of just basic inequalities as well. But we want to look at this inequality and provide a solution in graphical as well as interval and inequality format. 2 is less than 2x minus 5, and 2x minus 5 is less or equal to 7. So we call it a compound inequality because it's used multiple times. If you add the 5 to both sides, we get 7 is less than 2x. Divide by 2, and you get 7 halves, or 3.5, is less than x, or x greater than 3.5. And then this side, you add the 5 to both sides, and we get 2x is less than or equal to 12. Divide by the 2, and x is less than or equal to 6. So if we look at that solution as a graph, that's the inequality. The graph would be 3.5 and 6, less than or equal to 6, greater than 3.5. So that's the graph. The inequality is 3.5 is less than x, which is less than or equal to 6. So when it's a conjunction like that, you see that x sits between both of those. And if you write an interval notation, I remember this from last year, you'd say 3.5 in parentheses, and you would say 6 in a bracket. It's those two. So those are the three ways you represent that solution set. Here we're going to have a disjunction. We divide both sides by 3. We get x is greater than 3. Or in this situation, we add the 1. We get negative x is greater than 6. So x is less than negative 6. So, or x less than negative 6. So if we plot these, we got negative 6, we got 3. We're going to go ahead and put an open circle on the 3, arrow that way because it's greater than 3, open circle that way. So that's the graph, and it's a disjunction because they go apart. As an inequality, we just write it like it is up above. X is less than negative 6 or x is greater than 3. Just one of those has to be true in order for it to satisfy the solution. And then finally, if you want to represent this in interval notation, since the arrow goes off that way, we go negative infinity to negative 6, parenthesis, because there's no closed circle. And then we union that with 3 to infinity. So that union means we join those two pieces together, that either one can be true. Now, if you look at your next set, in order for us to understand other inequalities, we have to understand absolute values. And absolute values, we have 3 steps for solving them. Number 1 is isolate the absolute value. And as you can see here, this absolute value is already equal to numbers, so that's isolated. In this situation, in the next one, if we add 4 to both sides, we get 2 times the absolute value of x plus 5 is equal to 24. Now, if we divide by 2, we get absolute value of x plus 5 is equal to 12. So now that absolute value is isolated. Okay, so you have just an absolute value on one side. Second step is to set up 2 equations, a positive and a negative. So in this situation, we'll have 3x minus 3 is equal to 6. And we'll have 3x minus 3 is equal to negative 6. If I add the 3 to both sides, I get 3x is equal to 9. Divide by 3, I get x is 3. In this situation, I add 3 to both sides. I get 3x is equal to negative 3. Divide by 3, x is negative 1. So 3 and negative 1 are your 2 solutions. So after you set up the 2 equations, the plus and minus, you solve both, okay? So we solved both of those. We came up with our 2 solutions. So like in this situation, we have x plus 5 is equal to 12, and x plus 5 is equal to negative 12. Subtract the 5, we get x is 7. Subtract 5, and x is negative 17. So x is 7 and negative 17. That's our solution set right there. Okay. So what happens when we take inequalities and absolute values and we join them together? Well, let's look. Here you have an absolute value and a number, so it's already isolated. So I set up to x minus 4 is less than or equal to 6, and x minus 4 is greater than or equal to negative 6. So when you make one negative, you switch the sign for the inequality. We solve by adding 4 to both sides, x less than or equal to 10. And here we add 4 to both sides, and we get x greater than or equal to negative 2. So if you think about that solution, negative 2 and 10, I plot both of those. You got closed circles on each. X less than 10, x greater than negative 2. So it looks like they come together. It's a conjunction. And I knew that because when I had the absolute value isolated, you can see that the symbol is a less than. And is a conjunction. It brings two things together. So that's how I remember that I knew I was going to get that. If you want to write it in interval notation, negative 2 and 10, we use a bracket like that. That's our solution set. In this case, we have 2x minus 1 is greater than 5. 2x minus 1 is less than 5. So if I add the 1, I get 2x greater than 6, divided by 2, x greater than 3. The next one, we add 1, we get 2x less than 6. Oh, I forgot the negative sign, sorry about that, negative 4. 2x, divide by 2, x is less than negative 2. So if you plot those, plot the negative 2, plot the 3, got an open circle on negative 2, got an open circle on 3. Less than negative 2, greater than 3. So you can see they go apart there. It's a disjunction. We would say the solution says negative infinity to negative 2, union with 3 to infinity. Now, I knew it was going to be a disjunction because I see instead of a less than sign, I see a great or than sign. And so kind of change it from a greater to great or. It tells me it's going to go apart. So we'll see how you can apply this in the next two problems, figure out which one they're going to be. Here in this situation, I have an absolute value inequality. What I need to do is I need to isolate the absolute value. So I add 6. 3 times the absolute value of x plus 4 is less than 15. Now I'm going to divide by 3. Absolute value of x plus 4 is less than 5. And now I go ahead and I set up two inequalities. X plus 4 is less than 5, and x plus 4 is greater than negative 5. Now look at the symbol. It's a less than, so it's going to come together. It's a conjunction. Subtract 4, x is less than 1. Subtract 4, x is greater than negative 9. So you can see as you plot these, plot my negative 9, plot my 1, open circles on each, greater than negative 9, less than 1. So you can see it's a conjunction. They come together. So you knew your solution was going to look like this. Tells you ahead of time. And for both sides, we get negative 2x minus 4 is greater than or equal to negative 2. Now divide off that negative 1, and you get the absolute value of 2x minus 4. Remember to switch the sign because you're dividing by a negative. Is less than or equal to 2. So 2x minus 4 is less than or equal to 2, and 2x minus 4 is greater than or equal to negative 2. Add the 4 to both sides. 2x less than or equal to 6. Divide by 2, x is less than or equal to 3. Here we add the 4 to both sides. 2x is greater than or equal to 2. Divide by 2, x is greater or equal to 1. So as I plot the 1 and I plot the 3, close circles on both, look at what we ended up with, a less than. So we know it's a conjunction, it's going to come together. Greater or equal to 1, less than or equal to 3. So my solution set is 1 to 3. And there you have it. There's a review of compound inequalities. So we did equalities the other day, but now we look at the less than and greater than symbols. And that's a nice little overview that can help you out. So we'll practice this later on. Good luck with your homework.